In this video, I am going to go over the efficiency problems on page 40, and I will do the problems on page 41 in a different video. Page 40 is pretty straightforward. There's a whole bunch of equations up here on the top of the page, and we're not going to need most of them for page 40. So when we look at efficiency, number 1 here. It says calculate the efficiency of a light bulb that gives off 40 joules of light from 200 joules of electrical energy. So when you are working with efficiency, what you want to do is the useful energy output and divide that by the total energy in. And then what we have to do is multiply that by 100 because we want it as a percent. So a problem like this, it's telling us that 40 joules of light is what is the useful output. So that's going to go on top. And we're going to have the 200 joules, that's the total energy in on the bottom. That equals 0.2. We're going to multiply that by 100, and that gives you 20%. Right, so that is the efficiency of that bulb. Now, this next one is a motor that does 60 joules of work from 240 joules of electrical energy. So the useful energy output, that is the 60 joules. The input, the total energy, is 240 joules. You're going to end up multiplying that by 100, and when you do, you should get an answer of 25%. Because when you do 60 divided by 240, that gives you 0.25. You multiply that by 100, it gives you 25%. For number 3, a radio that gives off 30 joules of sound from 360 joules of electrical energy. So the useful energy output, that is the 30 joules. The total energy in is the 360 joules. Again, we'll multiply that answer by 100%. You should end up getting 8.3% efficiency. So not very efficient, but that's what it is off of the numbers we're given. Number 4, the efficiency of a runner who produces 500 joules of kinetic energy from 2,500 joules of chemical energy. So what they're saying is this person is eating food, and the energy their body is getting from breaking down that food is at 2,500 joules. But they're only producing 500 joules of energy when they go running. So you take that 500 joules, that's the output, divided by the total energy input, which is 2,500 joules. You're going to multiply the answer by 100 again, and that gives you 20%. Calculate the percent efficiency of a student who takes 2 hours to do 30 minutes of homework. All right, so the useful output, that was the 30 minutes. That's what, in this case, that's what the teacher designed. They're saying this work should take you 30 minutes. But for whatever reason, it took this one student 2 hours. Now, I'm converting that to minutes because we need the units to be the same. So whether that person didn't really know what they were doing or they were just kind of messing around, looking at their phone, or whatever the case is, so that person is 25% efficient. Now I'm going to erase a lot of this. And we're up to number 6. What is the useful light output from a bulb of efficiency 25% when supplied with 600 joules of energy? Now this is getting a little different. I'm going to equation. Efficiency equals useful energy out divided by total energy in, and then we were multiplying all that by 100. Now they just gave us the percentage, so now I have to turn that percentage back into a decimal, 0.25 instead of 25%, and that's going to equal the work output divided by the work input. Now in this case, we have that 0.25. The work input was that 600 joules. That is what that bulb is being supplied with, 600 joules. So they want to know, what is the output? How much light energy is it giving off? So now all you have to do is take this 600, multiply it by 0.25, and that is going to give you an answer of 150 joules. Now the good thing with percentages, you can always go back and double check your work at the end. If you take this 150 divided by 600, you should get 0.25. You multiply that by 100, you get that 25% back. All right, so it's always good to double check your work. And what you should expect when you're doing these is things are not 100% efficient. So you should expect the work output to be a smaller number than the work input. So for number 7, it's doing the same kind of thing. What is the useful work output? So it's asking us for this top part of the equation here. From a motor of efficiency 60% when supplied with 1,200 joules of energy. So that's the input. So now we're working with 60%, so I'm going to make that 0.60. We're solving for the work output, and the work input is at 1,200 joules. So you take this 1,200, multiply it by 0.60, and that is 720 joules. Now, it should kind of make sense if it was 50% efficient and it's supplied with 1,200. If it was 50% efficient, then you would get an output of 600, right? It would be exactly half of this. So you have a little more than half, 60%. So you should expect your answer to be a little more than that 600 if it was half of it, right? You can always double check your work like that too. What is a useful sound output from a radio of efficiency 50% when supplied with 20 joules of energy? All right, so it's asking us the same thing. Starting off with this 0.50, it's asking us for the output. It tells us the input is 20 joules. So 20 times 0.5, 10 joules. Number 9 is asking us the same kind of thing. It's asking us for the output. So this person, it doesn't give us, well, all right, it gives us that 30%. So change that to 0.30. We have work output divided by that 200 joules, because that is the total amount of energy supplied. And what you end up getting is 60 joules. Now, number 10 is asking us for something a little different. How long does it take a student of efficiency 40% to do a 30-minute homework? So in this case, well, it's giving us this 40%. So I'm going to make that 0.40. Now, what's different about this is this homework was designed to be 30 minutes. So that is going to be the output. That's how long it should have taken. But what it's asking us to figure out is the total time. So that 30 minutes is going to go on top. And the total time is what we're going to put on the bottom. Remember, if the person's only 40% efficient, the amount of time it's going to take is going to be longer than what the teacher originally planned. If the person was 100% efficient, a 30-minute homework would get done in 30 minutes. But that's not the case in this one. So total time, so now what we have to do is these things will end up switching places. What you're going to get is total time is going to equal the 30 minutes divided by the 0.40 efficiency, right? Because what happens with this, a little bit of math here, you have to multiply both sides by the time. So what you have is the total time times this 0.40 is going to equal the 30 minutes. And then you want to get total time by itself. So then what you end up having to do is divide both sides by this 0.40. And that's where we get this 30 minutes divided by 0.40. So when you do this, the total time ends up being 75 minutes. All right, so it took the person 75 minutes to do something that it should have only taken 30 minutes. All right, so that's the page 40. We'll do page 41 in another video.